In this tutorial, I will demonstrate how to take a standard MetaHuman character and customize it with a completely original suit design. I will show the process of replacing the default outfit, integrating the custom assets, and finally animating the character inside Unreal Engine. By the end, you will have a fully customized MetaHuman ready for cinematics, games, or virtual production projects. I already had my MetaHuman character prepared. First, I drag the MetaHuman into the scene and resets its transform to ensure it was positioned correctly. Then I selected the character and went to File, Export Selection, where I exported the MetaHuman as an FBX file for further customization in external software. In Maya, I already had the custom suit prepared. The suit is a combination of some downloaded assets and some parts that I created myself, and all of the meshes have already been UV mapped. To keep everything organized, I selected all the suit meshes in the outliner and grouped them together by pressing Ctrl G. Next, I imported the MetaHuman FBX file that I exported earlier from Unreal Engine into Maya. This gives me access to original MetaHuman skeleton and mesh, which I can use as a reference for fitting and attaching the custom suit correctly. Next, in the outliner, I expanded the MetaHuman hierarchy and organized the character components using display layers. For the head, I selected the face mesh along with its facial bones, added them into a new layer, and turned off the layer visibility to keep the scene clean. For the body, I only hide the body mesh while keeping the skeleton visible, since the custom suit will need to be attached and skinned to the existing skeleton. At this point, you may notice that some parts of MetaHuman skeleton do not perfectly align with the custom suit, especially around the fingers and feet. Before proceeding, these areas need to be adjusted so that the suit matches the skeleton correctly. To make the joints easier to work with, I first reduce the joint display size, which provides a clear view of the skeleton and makes precise alignment much easier. Next, I manually adjust the MetaHuman finger joints to match the structure of the robotic suit. I carefully reposition each joint so that I align with the corresponding finger segments of the suit. This step is important because proper joint placement ensures that the finger deform and animate correctly once the suit is bound to the skeleton. Now it's time to bind the custom suit to the MetaHuman skeleton. First, I selected the root bone of the MetaHuman skeleton, then selected the main group containing all of the suit meshes. I went to Skin, Bind Skin to attach the mesh to the existing MetaHuman skeleton and prepare it for animation. As you can see, the suit is now attached to the skeleton, but the mesh deformation is not working correctly and some parts of the suit are breaking apart. To fix this, I turned the original MetaHuman body mesh back on. Then I selected the MetaHuman body mesh first, and while holding Ctrl, select the custom suit group from the outliner. After that, I went to Skin, Copy Skin Weights. This transfer the existing skin weights from the MetaHuman body to the custom suit. Since the MetaHuman body is already properly weighed to the skeleton, the suit inherits those weights automatically, saving a significant amount of time and eliminating the need to manually paint skin weights from scratch. At this stage, the skin weights have been copied successfully from the MetaHuman body, but the deformation is still behaving like a human character with soft skin and muscle. Since this character is wearing a rigid robotic armor suit, the type of deformation is not ideal. To achieve a more mechanical look, I need to adjust the weight painting so that each armor pieces is fully influenced by its corresponding bone. In other words, every rigid section of the suit should follow a single joint with maximum influence, rather than blending between multiple joints like organic skin. This creates a solid hard surface deformation and give the armor a much more realistic robotic appearance during animation. To demonstrate the skinning process, I will start with the fingers. First, I select the mesh and then right click and choose paint skin weights. Next, I locate the corresponding finger joint in the influence list, right click on it and select influence. With that influence selected, I set the weight value to 1 and use flood. This assigns full influence of that bone to the selected armor piece, ensuring that it follows the joint rigidly without any soft deformation. I repeat the same process for each finger segment, assigning every armor pieces to its corresponding bone. This creates the rigid mechanical movement needed for a robotic armor suit and avoids the organic skin-like deformation that comes from traditional character skinning. Next, we need to clean up the weight influence on the palm section. Since some of the fingers joint may still be affecting the palm, those unwanted influence need to be removed. For each finger joint that has weight assigned to the palm, I select the corresponding influence, set its weight value to 0 and use flood. This removes the finger joint's influence from the palm completely. As a result, when the fingers rotate and bend, the palm remains unaffected and deforms correctly. This helps maintain clean, rigid armor deformation and prevents unwanted movement between separate mechanical parts. Next, I will work on the neck section that was excluded earlier. Just like before, I first select the root bone of the MetaHuman skeleton, then select all the neck related mesh pieces with the skeleton and meshes selected. I go to bind skin to bind the neck armor to the existing MetaHuman skeleton. Separating the neck from the rest of the suit allows for better control during the binding process and helps ensure that the neck pieces deform correctly with the character's head and upper body movements. After binding the neck section, I tested the deformation by rotating the head bone. As you can see, some areas of the neck armor are not deforming correctly. I also noticed that when moving the chest section, parts of the inner body geometry start to poke through the armor. To fix this, I selected the chest armor piece first and then select the corresponding inner body mesh. Just like before, I used copy skin weights to transfer the existing weight information. This immediately improved the deformation and resolved the issue. Then continue the same verification process for the rest of the spine chain, testing each bone and correcting any problematic areas as needed. By checking the deformation bone by bone, it's much easier to identify and fix weight issues before moving on the next stage. At this point, there is some distortion in the neck area, so we need to define the skin weights manually. First, I select the affected mesh and open paint skin weights. Then I locate the relevant joint in the influence list, right click on it and choose select influence. For the neck area, I select the head bone influence, and while holding shift, I use the brush to smooth the weights between the neighboring joints. This blends the weight values more gradually, creating a smoother transition between the head and neck influences. As a result, the deformation becomes much cleaner and the unwanted distortion is reduced. I repeat the same process on the remaining neck meshes until the entire neck section deforms smoothly during head movement. Once all the skinning and weight adjustment are complete, the custom suit is ready to be brought back into Unreal Engine and used to replace the character body you see here. Back in Maya, I first select the root bone of the skeleton, then I disable joint section and drag select all of the character meshes to make sure both the skeleton and the suit meshes are included in the export. After that, I go to File, Export Selection and export everything as an FBX file. Make sure to give the file a clear and recognizable name before exporting. Open the FBX export option and ensure that animation is enabled. This step is important because the skeleton data is exported through the animation settings. If animation is disabled, Unreal may not recognize the skeleton mesh correctly during import. Next, navigate to the appropriate folder in Unreal Engine where you want to store the custom suit assets. From there, click Import and select the FBX file that was exported from Maya. Before importing, make sure that the import content type is set to geometry skin weights. Also, ensure that import animation is disabled since the file is only intended to contain the skeleton mesh and skin data, not any animation. Once the import settings are configured correctly, click Import. Unreal Engine will import the skeleton mesh along with the associated materials, making the custom suit ready to be connected to the existing MetaHuman character. Now select the imported skeleton mesh and then click Edit Blueprint on the MetaHuman character from the outliner to open the character blueprint. Inside the blueprint editor, select the existing body component. Then in the content browser, select the custom suit skeleton mesh that we just imported. Return to the blueprint editor and replace the default body mesh with the custom suit by assigning it to the body component. After replacing the mesh, the character will now use the custom suit while still retaining all of the MetaHuman functionality and animation. If you notice any backface rendering issues or missing polygons, open the suit materials in the material editor and enable two-sided for each required material. This ensures that both sides of the geometry are rendered correctly and prevents any unwanted transparency or visibility issues in the armor. Once the custom suit has been assigned and the material settings have been adjusted, click Compile in the blueprint editor to apply all the changes. This updates the blueprint and ensures that the new skeleton mesh is properly integrated with the MetaHuman character. Next, open the level sequencer, then drag the MetaHuman blueprint from the outliner into the sequencer to add the character to the scene timeline. After that, click the plus track button and add the character body skeleton mesh. To bring in the animation controller, click plus track again, navigate to control rig and then enable filter asset by Animatable control from the available options. Select the MetaHuman control rig. Once the control rig is assigned, all of the MetaHuman animation controllers will become available in the sequence, allowing you to animate the character directly using the rig controls. At this point, I tested the setup by moving and rotating the various control rig controllers. This is an important validation step to ensure that the custom suit is responding correctly to the MetaHuman skeleton and rig. As you can see, all of the controllers are functioning properly and the armor deforms as expected without any major issues. This confirms that the skinning, weight transfer and mesh replacement process has been completed successfully and the character is now fully ready for animation. To set up facial animation, select the character face component in the sequencer, then click plus track, go to control rig and enable filter asset by Animatable control from the available options. Choose the appropriate MetaHuman face control rig. Once the face control rig is assigned, all of the facial controllers will become available in the sequencer. As you can see, the face controls are now accessible, allowing you to animate facial expressions, eye movement, lip sync and other detailed facial performance directly within Unreal Engine. At this point, I want the character to perform some movement, so I downloaded an animation from Mixamo beforehand. I will use this animation as a quick way to test the rig and bring the character to life inside Unreal Engine. In the next step, I will import the Mixamo animation and apply it to the character, allowing us to preview how the MetaHuman suits behave during full body animated performance. Now to use the Mixamo animation with the MetaHuman, right click on the animation asset and choose Retarget. A new window will open. In the visualization section, assign the custom MetaHuman character so you can preview how the animation will look on the final character. Next, double click the green retargeted animation asset to open it. Once you are satisfied with the result, click export animation. This will create a new MetaHuman compatible animation asset and save it to your content browser. After that, return to the level sequencer, drag the MetaHuman character into the sequencer again. Click plus track and add the body component. Then click plus track once more. Go to control rig and choose the layer control rig option. This will add the MetaHuman controllers while preserving the underlayering animation. Next, click plus track again, go to animation and assign the retargeted animation that was just created. The character will now play the imported animation while still allowing manual adjustments through the control rig. One of the biggest advantage of using a layer control rig is that if any body part doesn't interact exactly the way you want, you can simply select the relevant controller and make pose adjustments on top of the existing animation. This gives you the flexibility to refine individual movement without having to edit or recreate the entire animation. And that's it. Our custom MetaHuman suit is now fully integrated, animated, and ready for use in cinematics, game, or real-time projects. Thanks for watching, and I will see you in the next tutorial.